Hello everyone, today we are doing message to Garcia room on TryHackMe, which is based on encryption and key management challenge. On the task 1, we can see a little bit information about what is message to Garcia. It is basically about an employer who basically performs all of his tasks on time without even asking and doing it the right way. If you want more information about what is message to Garcia, you can just search it up on Google, but that does not matter much as for now. For completing the first task, it is just asking you the name of the lieutenant who delivered the message to Garcia, and that is basically Lieutenant Rowan. We're going to enter that here. We are done with the task 1. We're going to start the machine for the task 2. And it says, can you find your way in? So we have to find a way into the machine and potentially do the tasks that are mentioned here. Alright, so our machine is up. We are going to browse over to it, and we can see here it says introduction. Our goal is to securely deliver a message to Garcia by discovering and exploiting the vulnerabilities, getting unauthorized access to sensitive server resources, and using the obtained information. We have to complete the cryptographic challenge. Alright, so right here we can see here it says securely deliver an encrypted message using PGP encryption and interact with the API to validate and submit the message. We have 4 options here. Instructions, which we saw before. It says explore the application, discover additional functionality, explore the server to obtain the cryptographic key material. And step 3 is to prepare and encrypt the required message and then deliver it to complete the mission. Alright, so oops, I accidentally clicked over here. Okay, so we have a backup system, we have resource fetcher and option to restart the challenge, I believe. Okay, so we're going to open the backup system first. Let's take a look at that. So it says upload any file with a custom file name or path. Back to the main challenge, going to the resource fetcher option. We can fetch any resource. It could be external or local, which is interesting. We can see here it says it mentions file protocol using which we can read the local files. Alright, so we can try to read the etc password file. Let's do that quickly over here. And we can see we can read the files. Okay, so we have potential way to read the local files on the system, and we can see here Ubuntu is a user here. We can see its home directory is home Ubuntu, and if you search for the bin bash, you can see all the users on the machine. So the first one is root, and then we have the Ubuntu. There's no other user on this machine which we can SSH into or potentially change the user to. So we have explored this functionality. Let's go back to the backup system. Let's see what it does. So we can enter the custom file name here. Let's do test.txt, for example. We're going to browse for any file that we have to upload or we want to upload. So I'm going to create a file here. Let's name it test.txt, and I'm going to input here something. Let's click on edit, close it, select this file, and then click on upload. Now we can see here it says file uploaded to the path. Now we have the exact path where this file is uploaded. Now my first guess is to maybe we can access this directory, maybe. So I'm gonna put that here, and but it says not found, so this is not accessible. Maybe uploads is accessible. Again, this is a guess, and no, it is not. Let's try running fuck here really quickly. So I'm currently on Windows, but I use Linux as a WSL. So I don't use VirtualBox or dual boot because it slows down my system. So I'm going to go into the TryHackMe folder, and then I'm going to press Ctrl+R to search the last used fuff command, and I can see it here so that I can easily and quickly run the fuff command again. So let's input that here. Now this is the first keyword. We want to first the directories or files. We are going to use the common.txt file, which is from seclist, and we are going to use the 100 threads. Press enter, and our fuff is running, and we should see the results pop up on our screen, and we can see backup and fetch already being detected. Okay, it's done. It was really fast. Start, status, stop, success, and upload are the new findings that we have. Upload is, I guess, this one because we uploaded it here. So we can quickly check that. So let's do that again. Test.txt. Browse this file, upload. Okay, it sends a post request to backup. All right. So we have explored backup. We have explored fetch, the one where we found the LFI. Start, let's see what is a start. So I'll change this to start. Okay, so this is just the start of the challenge, I guess. Okay, then we have status option. Let's try that out. It says SFTP server manager, server status stopped. Now I'm going to click the network history and then click on start server just to see what it does. And as soon as we clicked on get, we saw this page. So it looks like we were redirected, I guess. And yeah, in the response headers, we can see location to be slash, which is basically redirected us from the start to the home page. Okay, so I guess this is starts the challenge, I believe. And then we have stop here, which should stop the challenge if I don't know. Okay, then we have success and upload. Let's try that as well. So going over to the success, I'm just gonna close this. There's access denied, complete the challenge first. Okay, so we have to complete the challenge first in order to get the flag, I believe. And then we also have the upload option, which just says method not allowed. Okay, so let's see. Okay, let's go back here. Did I copy the path? I did. No, I did not. Okay, so let's do that again. Test.txt, browse for the file here, click on upload, and we have the path here. Let's try reading it using the fetch utility. I'm gonna find file here. Okay, I did something wrong. Okay, we have an extra space here, that's why. So let's do that again. And now we have the file that we uploaded. This is the test file. Perfect. I don't know if you have noted this thing or not, but notice this directory. So I'm gonna paste it here, and then I'm gonna upload it once again. Let's say I'm gonna name it this time something else. Still, and then upload it again. And note that the directory name still remains the same. I thought this was randomly generated, but when you take a closer look, it's the same. So we can see that this is a path is not dynamically generated, but is existent on the machine, which does not change. This upload directory is also there. So using this file read utility, we can actually see what this process is being run as in the command line. For example, what I mean to say, let me explain. So whenever you run any Python script, let's say we run something as, let me show you or demonstrate it live here on my machine. So I'm gonna create a quick script and which is gonna print hello world. So let's see, it's gonna print hello world, and then it's gonna wait for my input. So this is let's say input here, and now if I run it, I have to run it, of course, by specifying Python and then script.py. It says hello world input here. As soon as I press enter, it will end. Now I'm going to look at the running processes right now, and here we do not see Python. But grep for Python here, you can see here there's nothing right now. So let's do it once again. Python script.py. So now our Python script is running. And now if I do the same thing again here, you can see here it says Python script.py. So it found the running process. Now this process was started using this command python script.py. Now you can take a look this away in the Linux machines to actually enumerate the processes and the command line using which those processes were initiated or started, such as I started tmux using the tmux keyword, and other things like cron is being running on the system, so this was started by cron-f command. Similarly, our script was started by typing python script.py in the command line. So in the same way, these things can be enumerated by going into the proc utility, I guess. I can't exactly remember. Maybe it's proc1 cmd line. Yes, that's right. So first is the, I guess, the process ID. If I go into ps-ef and get for 1, we can see here this is the process ID, and this is the output that we saw earlier. This is the command line using which the process was started. Again, ps/ef, you can see this is the process ID. So we can enumerate using the process IDs. So I can type in 556 to see the command line of our process. So it says python script.py. And note that it ignores the white spaces. So you'll see it without spaces. So we can do the same thing here as well. So if I do here file and then proc1 cmd line, press enter, you'll see it says spin init. So using this, we can see how this web application is running, using which command line, so that we can get more information on this application. So for that, I'm going to use burp suite because we have to enumerate or brute force these IDs from 1 to 1000 because there are a lot of processes running on these machines. So let me open up burp. Here I'm going to turn on the intercept and turn on my proxy. Then I'm going to send the same request that I sent right now, which is this. Click on fetch. We're going to fetch the request here, send it to the intruder, and turn off the intercept. That's it. So we have completed our first step. I guess this is not visible to you. Let me change the display font. All right, so I hope it's now readable. So we can see here this is our payload and it is encoded. So it is file and then proc1 cmd line. I'm going to add our payload here and go to the payloads, go to payload type as numbers from 1 to 1000 with a step of 1 each time, and then I guess that's it. Let's start our attack. And usually when I do this, I instantly pause after a few requests has been sent just to check that everything is as what we planned. So post request was sent, and in the response we can see 302 found, a set cookie, a session equals to EYJ whatever, and okay, we did not explore the cookies. So this is a very good indicator that we are running as Flask. The session cookie is usually stores the alert messages inside this. So if you remove this cookie, you won't be able to see the error message or the success message which the application is trying to print on the web application. So this is a very good indicator that this is a Flask box. And okay, so we can see here it says redirecting to fetch. So it is redirected to fetch before showing us the actual result, and we are not catching the redirects. So I have to close this, discard this, go to the settings, and then here we can potentially change this setting. Yeah. So here click on redirect always and process the cookies in redirections. Then start this attack. And now we can filter by the length. So if we have found something, its length will be much lengthier than the one where we have not found anything. We can see here it's 2962 with a payload of 646. If we go to the request 2, we can see here a cookie of course has been appended, and this cookie will you can see here this cookie is very lengthy than the one we had before in the request uh, uh, in the previous one that we saw. So and it's because if the output is much lengthier, this cookie will be lengthier as well because it contains the alert messages in the encoded format, which is how the Flask works. And in the response, we can see here our file content is printed here, Docker. So this is something about Docker. Now I'm gonna select this, paste it here so that it is easier to find the results. I'm gonna go over here and then click on arrow button. So we just straight on jump to the results. So again, this is something about the Docker debug daemon, and this one is about Python 3 upgrades. Not interesting. So we are gonna go over to each one of these one by one until we see something interesting. So this is about Nginx. We can see your Nginx master process is being run over here, and then going again, you can see it's about some agent. Not sure what that is. Now, okay, this one is interesting. So bin bash home ubuntu. This is the same directory that we found before. there's a start.sh script which is doing something. So let's see what that is. Start.sh fetch. And here we can see this is the startup script for the message to Garcia application. So this is this startup script that is actually starts this application. We can see it checks if the virtual environment exists. If it does not, then it creates one virtual environment, installs the required dependencies, creates the virtual environment, and then activates it. Then it generates the encrypted message if it does not exist, and it checks for the message.enc file if that exists in the current directory or not. If it does not, it creates it using the Python 3 create message.py Python file, and it starts the Flask application. So we were right with our guess that this is a Flask application, which indeed came out to be true. And then it echoes out the starting Flask application, which will be available at port 5000. And then it starts the application using app.py script. So we have found how this application started and using which utility. We have also found that message.encrypted file here resides in the same directory. So let us quickly grab the message.enc file, and here we have the file contents. Perfect. I'm going to copy this, and let's go back. Oops. Okay, so we can actually upload the message.enc file here. So I'm quickly going to open VS Code here just to create a new file. And we have the text file here. I'm going to replace it with the contents that we have found. And I'm going to rename this file to message.enc. Go back, click on upload, click select this, upload this, and we have the flag here. Perfect. So we have completed one of our tasks, which is what is the flag. So it says there's a problem. Okay. Remove the space and then try again. Let me refresh the page. Yeah, that works. After refresh. Now we have few tasks to do, which is what is the message that needs to be delivered, what is the encryption key, and other things. And let's go back. Go to the resource fetcher. Okay, we saw that app.py also exists on the same directory. Take a look at that. We see here it imports few of the libraries such as OS and then Flask and SFTP server instance. And from functions, I guess this is a directory, or maybe no, this is not a directory. This is a file. So there's a functions.py file, and inside that are these functions, which is valid GPG file, ensure upload folder, and this validate encrypted message. So this file is the main file that starts this server. We can see here it says app.run on the port 5000. Let's also quickly check out the file that creates the encrypted message, which was message.py. I believe we saw it in the start.sh file. And no. Okay, so I guess we forgot the name, so I'm gonna revisit the start.sh script. Search, and we can see here, okay, it's create message.py. Okay, so it's create message.py, and this is a simple script to create the encrypted message for this challenge. So it is using the fernet. So if you do not know, fernet is a type of encryption method. No, this is not what we are looking for in crypto. So fernet is a type of symmetric encryption, and it is an authenticated cryptographic method in Python used to securely encrypting and decrypting data such as passwords or sensitive information using AES-128 in the CBC mode and HMAC authentication. So we know this is a symmetric based authentication. So we're going to close that and answer this first question, which is what type of encryption is the service using. So this is a symmetric type of encryption. And what implementation of authenticated encryption is the service using? And that is fernet. What is the encryption key? All right, so we have the encryption key here. We can copy paste it here really quickly. And what is the message that needs to be delivered? And the message that this needs to be delivered is this. Copy that, paste over here, and okay, that completes our room.